Okay, let's dive into some truly mind-bending territory today.
Sounds good.
We've got source material here that really challenges our fundamental assumptions about reality itself, specifically from something called motion theory.
Right.
And the big question, the really speculative one right out of the gate is, what if the universe isn't, a finished, static thing? What if it's the result of an ongoing process, a refinement?
That's the core premise, yeah. It's fascinating. It starts with this foundational idea that motion isn't just what things do, like a ball rolling across a floor.
Okay.
Instead, motion is the fundamental stuff. Things are motion
Yeah.
at the deepest level.
Things are motion. Okay.
And building on that,
Yeah.
you get this concept that the universe we see, the one we inhabit, is the product of recursive refinement.
Recursive refinement.
Yeah, think of it less like a single one-off creation event.
Like the Big Bang, traditionally.
Exactly. Think of it more like a cosmic feedback loop, something that's been iterating, kind of learning, improving maybe,
Yeah.
over absolutely immense timescales.
Right, so it's suggesting our universe isn't like the first draft.
Not at all.
It's more like the latest version, the most stable configuration that's been achieved through, well, billions of these cycles you mentioned.
Precisely. And the source material teases that this pattern, this recursive motion, this idea of things refining themselves through repetition,
Yeah.
it's something we can actually see everywhere. If we know how to look for it, that is.
Okay, that's intriguing.
And what's really insightful, I think, is how it flips the script on stability.
How so?
Well, we think of things like protons or atoms as incredibly robust, right? Almost permanent.
Sure, fundamental building blocks.
But this theory suggests their robustness isn't because they were perfectly designed from square one. It's because they are the survivors. Survivors of this massive cosmic trial and error process.
Yeah.
They represent the patterns of motion that just happen to hold together the longest, the most effectively.
Wow. Okay, so for this deep dive then, our mission is basically to unpack this really wild perspective. How exactly does motion refine itself in this model? Where are these patterns showing up, like you said? And I guess what does this ultimately mean for how we understand the very ground of reality? Let's dig in.
Okay, so if we sort of zoom out for a second, this perspective really pushes back on the idea of a singular start point.
You mean like the Big Bang being the absolute beginning?
Exactly.
Right.
This model proposes the Big Bang wasn't the genesis of motion itself, not the very, very start.
Okay, so what was it then?
Perhaps the latest, most structured, maybe highest resolution phase
A phase?
of a much older continuous dance of motion that's constantly trying to find stable forms.
Okay, hold on. So if our Big Bang, our universe, was just a phase, what was the state before this current refined phase, according to this theory anyway?
Well, the source material paints a picture that's pretty different from, say, elegant quantum foam or a neat singularity.
Yeah. What does it describe?
It talks about something much messier. Raw, directionless turbulence, almost like a chaotic soup of unresolved rhythms.
That sounds nothing like the highly ordered cosmos we see today. That's the opposite of order.
And that's the central puzzle this theory tries to tackle, right?
Yeah.
How do you get from that primordial chaos
Yeah.
to the structure, the order, the stability we observe all around us?
And the answer is this recursive feedback loop.
That's the proposed mechanism. The key seems to be whether motion can synchronize. Can it sync up with itself or with other nearby motion?
Synchronize. Like finding a rhythm.
Exactly like finding a rhythm. When motion loops back on itself and manages to lock into a repeating synchronized pattern, it temporarily stores form. It creates a fleeting structure.
Okay, temporarily. But what happens when it fails? When it doesn't sync up?
That's crucial. When it fails to sync, it collapses. It falls apart back into that turbulent field.
So the failure isn't just wasted energy. It serves a purpose.
It absolutely serves a purpose. That collapse isn't just noise, it's information. It feeds back into the field, as the source puts it.
How does it feed back?
It subtly alters the conditions. It changes the probabilities, just a tiny bit, for the next attempt at forming a pattern. It's like motion is constantly experimenting.
Without a brain, though.
Without a brain, of course.
Right.
But it has feedback. Constraints emerge from this process. And over these vast timescales, the structures that manage to hold stable, even just briefly,
Yeah.
they reinforce their own patterns. They make it slightly more likely that similar patterns can hold tighter in future iterations. It bootstraps itself.
Okay, here's where it gets really interesting for me. The iterative nature. The source talks about this playing out over countless passes.
Like levels or rounds?
Yeah. Imagine motion starting as just that completely crude, random flow you described. Pass one, maybe, I don't know, a very rough, unstable spin forms for a microsecond, then collapses.
Right. Gone.
Pass two. The feedback from that collapse maybe slightly favors spins, just a tiny bit, so perhaps a slightly more stable one emerges this time. Lasts a fraction longer.
And you keep iterating. The theory speculates that maybe after, say, past 17, just pulling a number out of the air, you might get a pattern of motion stable enough to look something like a very volatile proto-proton.
Okay, but still unstable.
Oh, very unstable. Prone to decay almost instantly. But crucially, it lasts longer than anything that came before it in those earlier passes.
And then you just keep going.
You keep going through billions, maybe trillions of subsequent passes, billions of collapses feeding back information, billions of refinements. That proton pattern becomes incredibly well-tuned. It gets locked into a stable rhythm.
So stable that by, past 3 million maybe?
Could be. By some vastly later pass, it's so stable it can hold its form for billions of years, stable enough to even orbit with an electron and form a hydrogen atom.
So what it's describing is a kind of cosmic evolution, isn't it?
In a way, yes.
But the selective pressure, the thing being refined, it isn't biological DNA. It's sync stability.
That's a great way to put it. Sync stability.
Yeah.
What manages to loop stably persists.
Right, and what persists gets refined through all that interaction and feedback.
Exactly. And what refines, well, eventually, it becomes the fundamental particles, the atoms, the basic stuff that makes up reality as we know it.
That's the core process, then, this recursive refinement driven by sync stability.
That's the core process laid out in this model, yes.
Mm-hmm.
And what's fascinating is how the source points out that this pattern, this recursive dynamic of stable forms emerging from turbulence and then maybe shedding parts or refining further, it's not just cosmic. We can observe analogous things in totally different systems.
Oh, absolutely. And the examples it gives are great because they make this really abstract idea feel more tangible.
Like what?
Well, it mentions how weather systems work, right? How you get hurricanes forming out of general atmospheric turbulence.
A stable structure from chaos.
And then those hurricanes often shed smaller vortices off their sides. Or think about galaxies. They form these stable spirals, but they also throw off satellite galaxies or streams of stars.
Yes, exactly. And it scales down, too. It even suggests that something as simple as you breathing out
My breath.
creates tiny temporary vortices in the air around you.
Yeah.
We see this in fluid dynamics all the time, the concept of vortex shedding.
Where a stable swirl kind of detaches from the main flow.
Precisely. And this theory is speculating that on a cosmic scale, the universe is doing something similar. It's motion-shedding structured motion.
So our stable particles, atoms, stars, they could be like these incredibly refined vortices.
Vortices shed from a deeper, more fundamental flow of turbulent motion. And potentially, they themselves could be shedding even more refined structures into the future. Who knows?
So wait, this flips the standard picture then, instead of, say, stars forging atoms inside their cores.
Right, the usual nucleosynthesis story.
This motion theory kind of flips it. It's suggesting that motion itself, through this whole recursive feedback and refinement process, it forged everything.
Everything. The particles, the atoms, the stars, the galaxies. They aren't static objects created at one point. They are incredibly stable, incredibly deep rhythms that emerged by, as the source says, recursively collapsing into tighter synchronization.
Wow.
So the early hydrogen atom, from this viewpoint, it wasn't born perfect with all its properties fixed from the start.
Yeah.
It was more like motion's best draft at that particular stage of refinement. It was simply the temporary structure that happened to hold it sync the longest through that specific level of the cosmic game. That made it the dominant stable pattern for that era.
And the theory then takes that huge idea and makes it surprisingly personal. It suggests just like us.
Yeah, that's a powerful line.
If a universe is fundamentally this recursive structure, stabilizing itself through collapse and rhythm, then everything, from the tiniest quantum fluctuation right up to the incredibly complex patterns we experience as consciousness, it's all an echo of that same process. Motion learning, motion refining, motion stabilizing its own patterns.
It is quite a perspective shift, isn't it?
It completely changes how you think about just persistence, about existence itself.
It really does. It suggests that the solidity, the robustness we perceive in the physical world, it isn't some inherent property that was just, gifted at the beginning. It's an emergent quality, absolutely. Something earned through countless iterations of this cosmic scale trial and error.
So wrapping this up, the core takeaway from this deep dive, reading this source material, is that we really shouldn't look at our universe as some static, finished product.
No, definitely not. It's better understood, or at least this theory proposes we understand it, as a phase, or maybe like a specific level that's been achieved.
Achieved how?
In a grand, ongoing, recursive rhythm game.
Yeah.
It's motion constantly refining its own ability to hold shape to find that synchronization.
Which means, okay, when you look at the incredible stability of, say, an atom, or the persistent structure of a star, or even just the steady rhythm of your own heartbeat, the message is, don't just see what is there right now.
Exactly. See what it took to get there.
All those failed attempts.
The billions upon billions of collapses, the near hits, all that raw, turbulent motion just trying to sync up, failing, feeding that failure back into the system as information, and trying again and again.
Until finally a rhythm held, a pattern stabilized.
And that specific, incredibly refined, stable rhythm. Well, that rhythm is you.
It really makes you appreciate the stability we take for granted in a completely different way.
It's not a given state. It's an ongoing achievement, the result of this incredibly deep, iterative, cosmic process.
Where reality doesn't begin, it loops.
It loops. And according to this provocative theory, that loop is still refining, still iterating even now. Definitely something to ponder the next time you just observe the stable, yet always dynamic world around you.